whatever we did for the mean, we can copy that one for the test hypothesis for the proportion. Okay, it's easy one, and we give you one question on the final. I'm not sure about it. Maybe 8.2 or 8.3. Probably 8.3. But it's test hypothesis or hypothesis tests for a population proportion. Okay. So a situation will be created. There is going to be a claim. That claim related to the proportion. Read the problem carefully because it's very similar to the mean to make sure which one is it. Okay, hypothesis tests or testing for a population. For a population. Okay, for the population proportion. Proportion P. So there's going to be a claim that you have to check it. Okay, so what you are going to do is just, you should have the red pen somewhere. Yes. So what you're going to do, there's going to be a claim regarding the proportion that you have to check it. Okay, you do exactly whatever we did for the mean. Step one is you determine the null hypothesis and the alternative hypothesis. Okay, so I just write step one. So step one, we are going to determine which one is it. You are going to determine the null hypothesis, the null and alternative. Okay, alternative hypothesis. And it's very much like the mean. There are three possibilities. You see, all of them are of this design. And there are three possibilities. The only difference is it's only be the z that we're going to use, and sometimes finding the p-value. Okay, there are three possibility. That's it. So the possibilities are going to be, the first one is when you set it up, okay, your H naught is going to be this time a proportion is going to be equal to the fixed number that you're given. Okay, we're just using the same method that we use for the mean. We always go with the equation. So the H1, the alternative, is going to be the fact that the proportion is less than P. Okay, less than P0. So you know that this is going to be called the left tail. And you are going to have a left tail test. That's case one. Okay, then we have a case two, as we did it. So what is going to be the case two is the fact that the H naught is P equal to the P0, and the H1 is that the proportion is greater than P0. So that's, as usual, is a right tail test. Okay, right tail test. That's 1, 2. And the third one is going to be the fact that H naught is the P equal to the P0, but the H1 is that the P is not equal to the P0. Different, the proportion is different from that number. And you know that this is going to be your two-tailed test. Two-tailed test. So very similar to the mean. Okay, any question? So one of these can happen. You are going to set it up. So that will take you to the step two. This is different. Step two is going to be your test statistic. Okay, so the step 2, the test statistic is going to be this formula. So we're going to compute the test stat test statistic. Okay, test statistic using this formula, using it's a Z format. It's going to be a Z format, but the special Z. So the Z or the Z naught is going to be equal to, remember the formula for the proportion, we did have the P hat. Okay, the P hat sample proportion minus a P0, and this would be divided by the P0 Q0. You already got the P0 from the formula. You can easily find the Q0. Okay, the P hat information would be given to R over N or X over N. You're going to find it divided by N. Okay, you know that all of them are inside the radical. So that would be your Z number. So as you can see, since this is Z, so your p-value would be evaluated from there. Okay, so there is no T cases. Okay, there is only one case, and that would be a C number. So you can't miss it. And step 3 is going to be your p-value. Okay, step 3, you are going to determine the p-value. Again, for the p-value, since it's Z, you are going to use the Z curve. Okay, using the Z curve. And for this one, you know that there are going to be 3 possibilities for the right, left tail, as you did it for the mean. Just repeat it here so that you have it. Okay, so the case 1 means if you have a left tail test. So in the case of the left tail test, this is going to be where we get the P is less than the P0. Okay, you know that this would be related to the finding the area. Okay, finding the area to the left. So this is going to be, we are going to find the Z naught, and this is going to be the Z naught, and then you find the area to the left. So this is going to be P value, not the proportion, that's a P value. I just write it P value so that you're not going to be confused with the lots of P that we have here. Okay, so it's like the Z case really. And for the right-tailed test, you got to be careful. Right-tailed test. This is where the proportion is going to be greater than P0. So the resulted curve is going to be this one. So this is going to be your Z naught. Okay. And you know that you are going to find this area, and you are going to find it, and then you know that you have to find the complement to get the area to the right. Okay, so that is going to be your p-value. And the third case, when it's different, it's going to be two-sided one. So two-tailed. Okay, two-tailed test is the fact that the proportion is different from whatever is given. Okay, and the corresponding curve is going to be, remember we have divided it into 2 different parts. So it's going to be again like a negative Z naught and the positive Z naught. So you have to find one of them and then divided by 2. So I'm going to write this one to be the P half, and this is going to be the P half as we did it for the Z. And the one that we recommend is this one, because that's just area to the left and you can easily find it. Okay, you can easily find it and then you multiply it. Okay, and then multiply by 2 to get these numbers right away. Okay, so only just knowing how you design it, but otherwise everything is very much similar to the whatever we did for the Z numbers. Any question? There is nothing special about the case of the proportion. It's easy case, but make sure that your Z number is different. You say that's it. P hat minus P0 over square root of P, P0 Q0 over N. I'm going to show you in a minute how we're going to do it. And the last step is going to be the conclusion. Are you done? So step 1, 2, 3, and we get to the step 4, which is the conclusion. The conclusion is if the p-value is going to be less than alpha, then you reject the H naught. Okay. So the step 4, the conclusion. Conclusion is going to be on the fact that if the p-value, okay, if the p-value, I don't write the p because of the projection of the proportion. If it's going to be less than alpha, as usual, reject the H naught. Otherwise, you know that you fail to reject or do not reject H naught, and then we're done. That's how you do the proportion. Very easy case. Any question? So let's try one in condensed form to see which type of information do we have to collect, and then we give you a situation and to see how we're going to get the information from the actual problem. Okay, that's it. That's proportion. 1 or 2 questions on the proportion for the final. Mostly 1. Okay, because we'd like to cover everything. I think from the previous part, I think I did include the box plot because the box plot is important. Other than that, it's all normal distribution and whatever we did on the test tree. Okay, as an example, there is a claim that we want to check it. This is just a condensed one. So you know how we design the problem, then we give you the actual one. So the case that the proportion is going to be, since it's a proportion that give you in percent, okay, the claim that is that the fact that P is less than 60%. Okay, this is given to you, which is going to be the same as 0.6. Then you want to check it, so you need information. You go around, you pick a sample, and you collect the following information from the sample. So the sample data are going to be the sample size, n is equal to the 250. Okay, alpha is 1, x or r. Remember when you go for the proportion, number of successes, 124, and you want to check this one against the alpha equal to the 1%, which is 0.01. Okay, so that's the case with this proportion. So the solution is going to be, we are going to set up the test is less than. So this is how you design your test. So the H naught is the fact that the P is equal to the 60% or 0.6. Okay, the H1 is going to be the one that's given to you. Is going to be less than 0.6. So you are going to have a left tail test. Okay, it's going to be left tailed test. Okay, that's a step 1. But you have to write it down. I'll check your quiz to see quickly to see if you did it all right. So then we have to find the test statistic. For this one, it's clear. Test stat. Okay, that's going to be test statistic. It is a proportion, so the Z naught is going to be equal to okay, is equal to the p hat minus p0 over the square root of, okay, p0 q0 divided by n. We have to provide all this information that we need. So we need to have p hat. So remind yourself that the p hat is going to be x or r divided by the total number, because two numbers were given to you. That's it. The bigger number is n, the smaller number is going to be x or r. So this is going to be 124 divided by 250. Okay, 250. If you use your calculator, and that gives you 0.496. It's like multiplying this one by 4. And if you multiply this one by 4, that gives 1000, and this is going to be the result. Okay, so I just, I just call this one 50%. We don't usually run that bad. I call it 50 or 0.5 because it's very close. So that's going to be the p hat. Now p0 is the number that you consider here. It's going to be 0.6. Then you have to find the q0, and the q0 is going to be 1 minus p0, which is going to be 1 minus 0.6 is going to be 0.4 or 40%. Okay, so the q0 is 0.4. Any question? Remember, the p hat should evaluate it from this formula, but the number that you pick over here is p0, so we can get the q0, which is going to be 1 minus p0. And now we are ready. So we are going to substitute. The z naught is going to be equal to the p hat of the 0.5, okay, minus the p0, the p0 of the 0.6 divided by the square root of p0 q0. You have the 0.6 times it by 0.4 and then divided by n. Okay, if you use your calculator, this is the way I did it. Is a negative 0.1 here, and I have the denominator as 0.03. So I got negative 3.33. So this is my z number. So the z naught of negative 3.33. So that's going to be the second step to get the test statistic. Okay, any question? Now we have to find the p-value. Next step is going to be p-value. Okay, for the p-value, we know that we have a left tail test. Okay, left tail test. So the p-value, the probability is going to be the probability that z is going to be less than negative 3.33. So this is what we are interested in. Okay, we know that we get this number from the table quickly. I'm sorry, that is, it's going to be very small number. So if you check your calculator, this is going to be very small. It's a point, check the table, 0.004. Okay, so the p-value. So the p-value, just avoid the p for this group, is going to be 0.0004. Okay, I bring the alpha to compare. Alpha is 1%. This is not, it's very almost 0%. It's going to be 0.01. If you compare them together, the result is that the p is greater than alpha. When p is greater than alpha, do not reject the H naught, or means fail to reject the H naught. Okay, oh, I'm sorry, I did it wrong. Yes, p is less than alpha. Sorry about that. That's a p, that's alpha. P is less than alpha. P is less than alpha, so this means reject the H naught. Reject the H naught. you know that reject the echelon means you are in favor of the claim. So there is sufficient evidence to believe that, okay? So there is sufficient, okay, sufficient evidence to conclude or that the other way around, P is less than 0.6. Okay, so we support the claim. It's going to be the one. So support the claim. Support the claim. Okay, so it's very standard operation. We're not going to miss it. Okay, any question? Let's say we're going to handle it in real life when the actual problem is given. Okay, I have two examples. Let's see if we can do both of them for you. Okay, so this is the setting up the test. Okay, the echelon 3 possibility test stat is always the same. Make sure you have your formulas. Okay, and even you can use your calculator to get these numbers, but it's also very easy to get it. So let's see how we're going to handle it when the actual problem, actual situation is given. Okay, are you ready? Example. This is how we're going to see it as one question for the test or in general. And that's it. It's about the number of the people who are in favor of a death penalty. Okay, so this is a story in May. Okay, that's a real one. 2006. 2006, it is reported. Okay, result of the survey. It's reported that 65% of the people, of Americans, okay, 65% of the people favored, okay, they favored the death penalty. Okay, the death. A penalty for a person or a person convicted of a murder. Convicted of murder. Okay, 65% in favor. So what's the question? The question is, they repeat this survey again, okay, in October. Okay, in October 2006. October 2006, we asked 1,005 adult, okay, adult Americans have a question, ask a question that, question that are you in favor? Are you in favor of the death penalty? And, okay, penalty. And so they asked this question, the answer was 673. 673, they said yes. Okay, responded yes. Okay, so this is the two numbers that you are going to be interested in. 1,005 is a sample size, and the number in favor 673. So what is the question? And the question is that can one conclude? You see the number is going to be less, if you like, or is bigger. You see that's going to be around 75%. So the question is going to be, can one conclude? Can one conclude that more Americans, okay, conclude that more Americans favor the death penalty, the death penalty. So that's a question. So we want to use a test to check it. Yes, a test of significance. Significance with alpha equal to the 5%. Alpha equal to the 5% to support or refute, or do not. To support or refute this statement. It's kind of like the one that you got in your book. I mean, the wording. Okay. So the conclusion of this argument is that this question is a claim about the proportion that you want to check. Okay, you identify your claim and you set up the problem. Are you ready? So this is going to be the solution. So we identify the claim right away. So the claim is that the proportion, you see the actual number was 65%. So when they did it in October, you want to conclude that if we get more people, because this will show you, this is 67.3%. So you want to check if at that time, the number, the proportion of the people are going to be higher than 65% or 0.65. Okay, that's the claim that you have to check. So you need information, sample information, sample data. Sample data start with the sample size. We asked the question out of 1,005 people, and the 673 answered yes. And you want to check it with the degree of, okay, significant level of 5%, which is going to be 0.05. Okay, so you set up your test. So the test is going to be the H naught is the fact that the P is equal to the 0.65. So the H1 is the one that you are looking for, greater than, okay, 0.65. So as you can see, you are going to have a right tail test. Okay, this is going to be right tailed test. So that's going to be your step 1 question. Then you have to set up your test statistic. Okay, test stat, a statistic. So it says Z naught equal to the Z naught for the proportion. P hat minus P0 divided by the square root of, on the top P0 Q0 divided by N. Okay, so you have to find those P hat. So the P hat is going to be X over N. Your X is 673 people. N out of 1,000, 1,005. Okay, in 2005. So this number must be almost 67%. Okay, we call it 67.67, almost. So that's going to be a P hat. So your P0 is 0.65. You're going to find your Q0, which is 1 minus 0.65. Okay, and that would be 0.35%. Okay, so you have everything you need. So we go to the formula and you substitute to get the Z. So the Z naught is going to be the P hat of 0.67, P0 of 0.65, and down the bottom you have a P0 0.65 times it by 0.35 divided by N, which is 1005. Everything inside the radical, remember. Okay, if you simplify, the top is clear, 65, 67. So that gave you 0.02. And you can simplify the bottom one, and I did this one. This is what I got, you can check your calculator to test it. It's a 133. So the Z naught is going to be 133. That's going to be your, okay, Z stat or test statistic. Any question? Now you have to find the p-value. Remember, it's the right tail test. Okay, so this is how we're going to get the p-value. So what is going to be the p-value? You realize that it's a right tail test. Right tailed test. So your formula is going to be the p-value is equal to the probability that the Z is greater than, greater than 1.33. So you have to find whatever you find if you want to use your directly get the complement. Okay, it's going to be 1 minus the probability. I'm going to finish it here, so I write the result for you. So it's going to be on the table. It's going to be 1 minus, and for the 133, you get a 0.9082, which is going to be 0.0918. Okay, there's going to be area to the right. That's why you have to find the complement. Okay, there you are. So your P number is a very big one. It's almost 9%. Here 0.0918, and your alpha is 5%, which is 0.05. So this means P is going to be greater than alpha. Okay, fail to reject. Do not reject. So do not reject the H naught. So this means you like the H naught. So you have to reject the H1, and the H1 is the claim. Okay, so simply you can say that because they ask, do you support or refute the statement? The answer is going to be refute the statement. Refute the statement. Okay, do not reject the H naught means there is sufficient evidence. Sufficient evidence to believe the otherwise. There is sufficient evidence to believe that, okay, the proportion, and then this is it. Believe that the H1 is correct. So that the proportion is greater than 65%, and that's exactly, okay, what is this one? So do not reject the H naught means you like the H naught, that's it. So there is not sufficient evidence, okay? There is not sufficient evidence to believe otherwise, to believe that the P is greater than 65%. So you're not going to support the statement, or you're going to refute the claim, okay? So there is not sufficient evidence. When we say do not reject the H naught, means you like the H naught, so you have to write something negative for the H1. So the something negative means there is not sufficient evidence to believe that P is greater than 65%. And that's exactly the claim. So we don't support the claim. We refute the claim. Okay, I'll give you one more example next time for the two-sided one. And that's it. That's for proportion. Any question? We have one more for the standard deviation. A standard deviation, when you want to get the test, it's not difficult. Sometimes it's messy. So we are going to consider only one case, and I'm going to, because the calculator, I told you, you have to add the program into it to get it. I didn't get it on my TI-84 over here, so I have to download it from somewhere else. I was not able to go over here. I checked it a couple of times, but it can be done. So we just consider one case. That case can be, I listed for you. Okay, less than, greater than. The difficulty with the, because you have to use chi-square over there. And the chi-square, remember, would give you the area to the right. All of these give you the area to the left when we talk about z numbers or the t numbers. But for the chi-square, you got to be careful. You have to get the other side if you like. So if the situation is going to be the fact that the sigma is greater than something, that's easy. Otherwise, you have to find the kind of complement. There's an algebra involved, but it's not much difficult really. So we design that one quickly next time. We talk about it. We need something like 30 minutes to take care of it. And then we can start working on the final review. Okay, that's it. So we're done with whatever we have to do it by next lecture. So we start this new part and we do the proportion and the standard deviation right away from the review. And then we come back. You are going to have, that's it. We have the Thursday and the Tuesday, because I think your final is going to be next Thursday. It must be your last class. So we have time to get over it. Okay, and I grade your quiz so that I quickly find out if there is anything else we have to let you know. That's it. Any question? So check your test, correct it, and study that because you need it. And the assignment already, okay, update the date. It's going to be up to the final day. So nothing to worry about that. Okay, take care and see you on Thursday. Bye-bye.